Hi everyone, we are going to be starting our unit on polar coordinates today. So today we're just going to be going over the basics of what polar coordinates are and how to graph them, and then a little bit on how to go back and forth between our regular rectangular system and our polar coordinate system. So by this point in your math careers, you guys are pretty familiar with the Cartesian plane, or rectangular plane. So the Cartesian plane is just when you have your x and y coordinates. So obviously x goes with the left and the right, and then y goes with up and down. So if you have a point like 5, 2, you go over 5 and up 2, and that's how you find your point. Polar coordinates are, instead of being in a rectangular shape, they are circular. So this right here is our polar graph, and for polar coordinates, instead of having an x and a y, you have an r and a theta. So r is called your pole, and theta is called your angle. So what this measures is r measures distance from the center, distance from, I'm going to say origin, and I'm going to put radius in parentheses, and then theta measures the angle from x-axis. Sorry, this is getting a little bit messy. So if I have a point right here, and we're going to call that point P, and we go out to point P like this. So point P is going to have a radius and an angle. So the radius is going to be the length of this line here. So how many circles away we are from the center right here. And then theta is going to be this measurement right here, the angle measurement from our positive x-axis up to our line right here. So let's see this in action a little bit, okay? So we have our polar coordinate systems here. So again, they look different, they're circular. And if you'll notice, each quadrant has 3 lines drawn in it, and you can assume that these lines are representative of the pi over 6, pi over 4, and pi over 3 coordinates. So, or the 30, 45, and 60 degrees, and then that continues all the way around the circle. And then you can assume that each one of these rings is a distance of 1. So if we're looking at letter A here, we're looking for our point 2, pi over 3. So for me, it helps to find my angle first. So I know I'm going here, and I'm going up to pi over 3. So we know it's going to be somewhere on this line. And then starting at the origin, we're going to count out 1, 2. So this right here is point P. Now is where we start to get a little bit trickier, okay? So for letter B, it says Q is -1, 3 pi over 4. So -1 for a radius is a little bit, that's kind of scary, but let's deal with the angle first, okay? So we're starting here. We know this is pi over 4, 2 pi over 4, 3 pi over 4 is right here, okay? Then, so we know this is our angle of 3 pi over 4. What the negative radius means is it is on the terminal side of this angle, theta plus pi. So theta plus pi is going to be the line that is directly opposite from it right here. I'm going to use a brighter color because I feel like you guys can't really see that. Much better, I guess. So this angle right here is theta plus pi, and then we go out a distance of 1 because our radius is -1. So this point right here is going to be Q. Next up, we move on to letter R here. This has a radius of 3 and a theta measurement of -45. So our negative angles are the same as we did on the unit circle. We start here, and then we just go clockwise instead of counterclockwise. So -45 is right here, and then we're going to count on that line a radius of 3. So 1, 2, 3. So this right here is your point R. So the negative angle, negative theta, means you're going to be going clockwise from x-axis. All right, so those are some of your basics. All right, I want you guys to pause the video here real quick, give these two a try, and then when you're ready, press play and we'll go through them together. Welcome back. For letter A, we want to plot the point with the given polar coordinates 2, 5 pi over 3. So starting here, we want to find our 5 pi over 3. So we know our pi over 3's. We have 1, 2, 3, 4, 5. So we know it's going to be on this line, and it has a radius of 2. So 1, 2. So right here is going to be your point A. And now for letter B, we get to do our negative radius. So we need to find our angle that has a measure of 135 degrees. So that is going to be on our unit circle. That's going to be our 45-degree reference angle in the second quadrant. So remember, this angle right here is your theta. But since we have a negative radius, we have to go with theta plus pi, or theta plus 180 in this case. So we're at our 315 reference angle. So that's going to be along this one right here. And we're looking for a radius of -3. So 1, 2, 3. So that is our letter B. So for the sake of time, just so we don't have to watch a bunch of really long videos, I'm going to cut this one off right here, and then I'm going to come back with another video that is finding all possible polar coordinates.